Welcome pre-cal students to the homework help video, page 397, numbers 53 through 64 all, and numbers 65 through 75 odd. Hopefully this video will help you find your mistakes on your homework. Let's go ahead and get started. For number 53, they want us to evaluate the log base A of 2 over the log base A of 11. Now notice for these first 6 problems they've given us 3 bits of information: log base A of 2, log base A of 7, and log base A of 11. And so we do know the logarithm of 2, 7, and 11. So with that in mind, this was a pretty easy problem to start off with. Whenever your argument is a quotient, you can split your argument up into you can split your logarithm up into 2 logarithms. And so that's what we'll do. Your numerator went here, your denominator went here. And then log base A of 2 is 0.301. Log base A of 11 is 1.041. And if you subtract these two, you will get negative 0.74. And you can try that if you want to. You will see you'll get the correct answer. Okay, moving on to number 54. Okay, log base A of 14. Now we don't know the log of 14, but notice we do know the log of 2 and the log of 7. So instead of putting a 14 here, I'm going to go ahead and put 2 times 7, which is the same thing as 14. And now we've learned that whenever your argument is a product, whenever they're multiplying, you can split that up into 2 logarithms: log base A of 2 plus the log base A of 7. And now we do know the logarithm of 2 is 0.301, and we do know the logarithm of 7 is 0.845. And when you add them together, you will get 1.146. Okay, there we go. Moving on to number 55. Now, I have here, let's see, I've got to think this through, the logarithm of 98. Now I'm trying to think. I'm wondering here, (49 times 2). Yes, that'll work. Okay, so here's what I know. You have to do a lot of thinking on these, students. Okay, I'm not saying it's going to be easy, but for 98 here, it dawned on me, if I take 7 squared, that's 49, and then multiply that by 2, I'll get 98. So you just have to take your 3 numbers that you know up here, logarithm of 2, log of 11, log of 7, and just kind of play around with them, okay? So it dawned on me, if I took 7 times 7, that's 49, times 2 would give me 98. So now I have a product here, so I'm going to rewrite my logarithm as log base A of 7 squared. But hold it, that 2 right there can really go to the left, and then plus log base A of 2. Now I do know the logarithm of 7, it's 0.845, and I do know the logarithm of 2, it's 0.301. Well, if you take 2 times 0.845 and then add 0.301 and go ahead and check it, you'll see you will get 1.991. Okay? All right, moving on to number 56. This one here is pretty simple. We don't worry about the 1 because we know the logarithm of 1. We don't care what the base is. So I have a quotient here. So log base A of 1 minus the log base A of 7. So I took my argument, that's a quotient, and I split it up into 2 logarithms. Anytime you take the log of A, it's always 0, and then the logarithm of 7 is given to you, 0.845. So obviously if you take 0 minus 0.845, you will get this right here, negative 0.845. Okay, moving on to number 57. Well, guys, I mean, it doesn't get any easier than this. Your numerator is log base A of 2. So up top here, I'm simply going to write 0.301. In your denominator, you have log base A of 7, and that's 0.845. So with your calculator, if you type in 0.301 divided by 0.845, you will get this right here. Okay? All right, moving on. Number 59. Well, let's see. We have a 9 here. I'm pretty sure, and I should have been checking my answers as I go. If you'll give me a second, I'm going to go back and check. I always want to check my answers and make sure. Of course, we've had the answers in front of us, haven't we? That's right. So we've checked them. 58. Yeah, that's what I thought. I looked in the book here. It cannot be done. There's no way you can take a 2 and a 7 and 11 and work with them and by using a product or powers or quotients and somehow get a 9 right here. It just can't be done. So this one cannot be solved with the information given. Okay? All right, moving on to number 59. Now notice they've changed directions on us, or changed information. Now we now we know the log base b of 2, the log base b of 3, and the log base b of 5. So those are the three numbers we're going to be using. And they want us to solve this logarithm. Well, students, I got to be honest. As soon as I see 125, I don't know about you, but as soon as I see 125, I'm thinking of 5 to the third power. I mean, that's just me. I mean, 5 to the third power is 125. So now I have log base b of 5 to the third power, which means you can take this 3 right here and write it out to the left of the log. So you have 3 log base b of 5. And we know the logarithm of 5. The logarithm of 5 is 1.609. Now, if you multiply 3 times 1.609, you will get 4.827. which does match our answer up here, number 60. Okay, now this one here is pretty simple because you have log base b of 5 divided by 3. And so I can just quickly write that as log of 5 minus, because we have a quotient here, log base b of 3. Okay, and now I do know the logarithm of 5. It's 1.609 minus, I do know the logarithm of 3, 1.099. Okay, so if you subtract those two, you will get 0.51. Okay, which does match our answer up here, number 61. Okay, notice how I have the log base b of 1 over 6. Now I'm not worried about the 1, okay? I can find the logarithm of 1, but this 6 here is kind of a problem. So I'm going to go ahead and make this 6 right here 3 times 2. Do y'all see that okay? So instead of having 1/6, I'm going to have 1 over 3 times 2. Now let's see what that does for us. Are you ready? I'm going to write log base b of 1 minus log base b of what? 3 times 2. Do you see what I did there? I have a quotient, I have a fraction right here, and so I can split this up into two logarithms. Now don't forget, this negative goes to this entire log, and now I'm going to split this logarithm up because I have 3 times 2. And by the way, why did I use 3 times 2 for 6? Because of right here. I know the logarithm of 2, and I know the logarithm of 3. Those are two of the numbers I'm dealing with, 2, 3, and 5. And so let's split this logarithm up. So now I have minus, and then parentheses, log base b of 3 plus log base b of 2. There we go. And then bring down this first logarithm. Actually, I'm not even going to bring that down. Remember, anytime you take the logarithm of 1, your answer is 0. So this whole expression right here just becomes 0. Okay? So basically what I have now is 0 minus, and then parentheses, the logarithm of 3 is 1.099 plus the logarithm of 2 is 0.693. And so if you add these two together and then take 0 minus that number, you will get negative 1.792, which is the correct answer. Okay, moving on to number 62. Well, I see a 30. I'm dealing with a 2 and a 3 and a 5. So the first thing I think of is for 30, I'm just going to write 2 times 3 times 5. 2 times 3 times 5. Okay? And that's pretty simple. Now I have just three logarithms, log base b of 2 plus log base b of 3 plus the log base b of 5. So really, we're just going to take 0.693 plus 1.099 plus 1.609, because that's what the log of 2 equals, and the log of 3 equals this, and the log of 5 equals this. Add them up and you will get 3.401, okay, which is the answer right here. Number 63. Now, I'm not too worried about the 3 up top here, because I know what the logarithm of 3 is. It's 1.099. This b might cause me some problems. Let's take a look and see. I have a quotient here, so I'm going to split my logarithm up into 2 subtracting logs like this. There. But I'm looking pretty good, because first of all, the logarithm of 3 is given to me up here, so I'm going to go ahead and put 1.099. And then we learned some properties that said whenever the base of the log matches the base of your argument, the entire expression equals the exponent, and your exponent is 1. Okay, let's go over that again. We learned a property that said whenever the base of the logarithm matches the base of the argument, the entire expression equals whatever the exponent is, which is 1. So this entire expression here just equals 1. So 1.099 minus 1 is obviously 0.099, which does match your answer up here. And then last but not least, this one here. Now I see the b, I think I'm going to be okay. I see a 15. When I see this 15, I'm thinking of 3 times 5. So instead of putting 15b, I'm going to put 3 times 5 times b, because 3 times 5 times b is 15b, and that's totally acceptable. And now I have log base b of 3 plus log base b of 5 plus log base b of b. Well, I know what the logarithm of 3 is. It's given to me 1.099. I know what the logarithm of 5 is. It's given to me 1.609. And then look, whenever your base matches your base, whenever the base of a logarithm matches the base of your argument, the answer is the exponent. And I have a 1 here. If I had a 2 here, then this entire expression would equal 2. I have a 1 right here, so this entire expression equals 1. So the answer is going to be 3.708, and you'll get that when you add all 3 of these numbers together, which does match your answer up here. Okay? Let me get a drink here real quick. And let's continue on. Okay, number 65. Now we're going to go really quick through these. These are the properties that we learned, the 3 new properties, and they go pretty quickly here. Whenever the base of your logarithm matches the base of the argument, your answer is the exponent. So this entire expression just equals 3. 67. Whenever the base of your logarithm matches the base of your argument, the entire expression equals your exponent. And so the answer to this logarithm would be this right here. Number 69. Whenever your logarithm is written as an exponent, which it is, and the base here matches the base here, then the entire expression equals the argument, and your argument is 4x. So the answer is 4x. Number 70. Now remember, this is a common log right here, so really you can rewrite your exponent like this. We can put a 10 in right here, okay? Whenever your logarithm is written as an exponent and the base here matches the base here, the entire expression just equals the argument, and the argument is w. So your answer is w. Number 73. Now remember, natural log means log base e, so there's really an e here, okay? So whenever the base of the logarithm matches the base of the argument, your answer is just the exponent, and the exponent is 8t. So your answer is 8t. And then last but not least, number 75. Now this one here is a little tricky, but all that you have to do is rewrite your argument with an exponent. The square root of b is the same thing as b to the 1/2. And there we go. Whenever the base of your logarithm matches the base of your argument, your answer is the exponent, and the exponent is 1/2, so your answer would be 1/2. Okay, I hope this homework help video has been a help to you. If you have any questions at all, don't hesitate to call or email.